Okay, now the next topic is dynamic linking. It is also one of the topic of loader design option. As the name indicate, the dynamic is the runtime or execution time only the linked your all program. The linkage editor perform linking operation before the program is loaded for execution. It is commanded before the loader is execution. But linking loader perform this same operation at load time. You get the difference between what is load time and what is not load execution time. Get what is dynamic linking? The dynamic linking, dynamic loading, or load on call. All are same. Dynamic linking, the dynamic loading, or load on call postpones the linking function until execution time. If your function load on call function is called, but it should be not done immediately, it should be wait until the execution time is start. When it is compiled, it will not do it. When the execution time starts, then only your program should be loaded for your memory. A subroutine is loaded. So a subroutine is loaded and linked to the rest of the program when it is first called is called as dynamic linking. This is the definition of what? Dynamic linking. You can see it. A scheme that postpones the linking function until execution time. A subroutine is loaded and linked to the rest of the program when it is first called. This type of function is usually called dynamic linking or dynamic loading or load on call. Dynamic linking is often used to allow several executing programs to share one copy of a subroutine or library file. For that purpose, we are using. Then dynamic linking for that. For example, runtime support routines for high-level language like C program. For example, with a program that allows its user to interactively call on any of the subroutine of the large mathematical and statistical library. All of the library subroutine could potentially be needed, but only a few will actually be used in any one of the execution. Now you are writing the big program. For the big program, you have so many subroutine, but all subroutines not always used. Only some one or two subroutines are maybe you are calling, and some of you only included. In that situation, what happens? Every time you go back to a subroutine, should be call the function, return the function you are doing. For that, dynamic linking can avoid the necessity of loading the entire library for each execution except those necessary subroutine. For that, we are using whenever you want only those library files to be only loaded for the memory, otherwise you not loaded for that execution. That below figure shows they illustrate a method in which routines that are dynamically loaded must be called via operating system service request. Assume you have a program, that program is called by your main program is called by some subroutine, and when you are calling that subroutine from the main program, and how that program should be loaded for the memory when the operating system is start servicing request. This diagram is very important. You should be write this diagram, and diagram can explain with the steps. See, the first one, you have a user program. User program is your main program that you can call a function for load and call. That function name is error handler. You can take one any subroutine, that's called error handler for calling your dynamic loader for load your program. It's a part of your operating system. What is step? Figure A is your user program call, load and call for this function for your operating system. See, instead of executing a jump JSON instruction referring to external symbol, the program makes a load and call service request to an OSC service request to an OS. The parameter of this request is the symbolic name of the routine to be called. This will be symbolic name of the routine to be called. What is the parameter? The parameter is the error handler. And what happens second? You see the second diagram. Whatever your load request go to this dynamic loader, the dynamic loader will be search your library. That subroutines is already there in the library or not. It will check from the library and is there or not, you will give it information. See the figure B. The operating system examines its internal table to determine whether it or not the routine is already loaded. Operating system examines its internal tables to determine whether or not the routine is already loaded. It will check. If necessary, the routine is loaded from the specified user or system libraries. That is, can we do it from this check is already there or not, or it can be explicitly should be loaded for that function. That is for the second diagram. What happens once that error handler in that library? What again that function will be the dynamic loader will call that subroutine function. What is subroutine function? That third one. This error again you get the request. If it is already there, then it should be called from the OS to your function. What happens? The control section is then passed from OS to the routine being called. Now that function calling function it's get. When it is called the function, what happens? The subroutine will be start executing. After executing that subroutine, it will return back to your main program. See, when it is called from this OS to the function is start executing. That return will be go to your loader and loader will return to your main program. That function is completed. Okay, this task will be done by figure D. Just check the figure D. When the called subroutine completes its processing, it returns to its caller. That is what OS. See, when it is completed, that error handler one it will go to loader. Loader will returns the caller function to use it. OS then returns control to the program that issued the request. That process is completed. Once the process is completed, what happens? See the figure 5. Once the process is completed from this, then user program will call for the loader. The loader will come to this. There's a completion here, one subroutine. If a subroutine is still in memory, check it. If a subroutine is still in memory, a second call to it may not require another load operation. Control may simply be passed from the dynamic loader to the called routine. That means if in case the same operation is called by that user program, no need to do once again, just only send a request and you will show that answer to the program. That is what you did. In the last one, control may simply be passed from the dynamic loader to the called routine. Okay, this is that steps will be doing when loading and calling of a subroutine using dynamic linking. They're very much important, the dynamic linking. These 5 diagrams and these 5 diagram explanations only carries the marks for 5 to 6 in your exam. That shows how this call the function can be done in that loading option. The binding of a name to the actual address is delayed from the load time until execution time. You know what is the static and what is loading. That should be delayed until your execution time is started. Okay, that is completion of your linking loader. The last one, dynamic linking. The next for the bootstrap loader. You know, when given an idle computer with no program in memory, how do you get things started? That's for how you know how I need to start it. On some computer, an absolute loader program is permanently resided in read-only memory. When some hardware signal occurs, the machine begins to execute this ROM program. Okay, this is referred to as bootstrap loader. In the beginning of the topic, only studied what is bootstrap loader, how it is done, but you get only the general idea about how the bootstrap loader can be done for this topic. Okay, now in this, the 3.4 section, loader design option, then load bootstrap loader, dynamic linking, and one for the linkage editor. These two topics are very much important. Thank you.